Today we are going to learn about mastering tensor operations in TensorFlow. By the end of this video, you will be skilled in implementing and optimizing tensor operations in your machine learning workflows. Welcome to our deep dive into mastering tensor operations in TensorFlow. Tensor operations form the foundation of machine learning models, allowing us to efficiently process and manipulate data. In this video, we'll explore how these operations are crucial for optimizing model performance and managing large datasets. TensorFlow, one of the most popular frameworks, provides a robust set of tools for implementing these operations. Understanding these concepts will enable you to enhance your machine learning workflows, ensuring they're both effective and efficient.
Tensors are the central data structure in TensorFlow. They can represent different types of data structures, such as scalars, vectors, matrices, and higher dimensional arrays. In TensorFlow, creating a tensor is straightforward. You can define a tensor using the tf.constant or tf.variable functions. Basic operations like addition and subtraction can be performed directly on tensors, which allows for efficient computation. Understanding the rank and shape of tensors is essential, as it helps to determine how operations can be applied. Let's look at some practical examples to cement these concepts.
Element-wise operations allow you to apply operations to each element of a tensor individually. For example, you can add two tensors together, and TensorFlow will add each element from one tensor to the corresponding element of the other. Broadcasting is a powerful feature that allows tensors of different shapes to be used together in operations. TensorFlow automatically adjusts the shapes of the tensors so that they can be added, multiplied, etc. Understanding how broadcasting works is fundamental for effectively utilizing TensorFlow in practical applications, but be cautious of dimensions mismatches which can lead to errors. Matrix multiplication is a crucial operation in many machine learning algorithms, particularly in neural networks. In TensorFlow, you can perform matrix multiplication using the tf.matmul function. This operation is not only fundamental for the forward propagation of neural networks but also plays a key role in backpropagation. Ensuring efficient matrix multiplication can lead to significant performance improvements. We'll explore some real-world examples where matrix multiplication is applied, highlighting its importance in training complex models and the considerations necessary to optimize these operations. Aggregation functions are essential for summarizing data. TensorFlow provides several reduction functions, such as tf.reduce_sum and tf.reduce_mean, which allow you to calculate the sum or mean across specific dimensions of a tensor. These functions are particularly useful when you need to compute summary statistics or implement loss functions in neural networks. Understanding how to leverage these functions effectively can result in more efficient data processing. However, it's important to be aware of the dimensions being reduced to avoid unexpected results. Tensor manipulation often requires changing the shape of tensors. The tf.reshape function allows you to change the shape of a tensor without altering its data. This is particularly useful in preparing data for model input or output. Meanwhile, the tf.squeeze function removes dimensions of size 1 from the shape of a tensor, which is useful for cleaning up data dimensions. Both functions are crucial for ensuring that tensors are in the correct shape for operations, helping to prevent shape mismatches and errors during model training.
Slicing and indexing are critical for accessing specific data points within tensors. TensorFlow provides advanced slicing techniques that allow for more complex data manipulation. The tf.gather and tf.slice functions are powerful tools for selecting specific elements or sections of a tensor. These techniques are essential when working with complex datasets, enabling efficient data extraction and manipulation. Understanding how to apply these methods effectively will allow you to handle large-scale data with precision and avoid common pitfalls associated with improper indexing. When dealing with large-scale computations, optimizing tensor operations is key to achieving high performance. TensorFlow's ability to leverage GPU capabilities can significantly speed up computations. Additionally, efficient memory management and the use of parallel processing techniques can lead to substantial improvements in execution time. In this section, we'll explore real-world strategies for optimizing tensor operations, ensuring that your applications run smoothly even when processing large datasets. By implementing these performance tips, you'll be able to maximize the efficiency and speed of your TensorFlow applications.
Debugging tensor operations can sometimes be challenging, especially when working with complex models. Common issues include shape mismatches, data type errors, and incorrect operation specifications. TensorFlow provides a suite of debugging tools that can help identify and resolve these problems. In this section, we'll cover effective debugging techniques and explore real-world scenarios where these tools can be applied. By mastering these debugging strategies, you'll be equipped to handle any tensor-related issues you encounter, ensuring your models run smoothly and efficiently.
As we conclude this video, let's review the key concepts covered. Tensor operations are integral to optimizing machine learning workflows, allowing for efficient data processing and model performance. By understanding and mastering these operations, you're better equipped to tackle a wide range of machine learning challenges. Whether you're building complex models or optimizing existing ones, tensor operations provide the foundation for success. Continue exploring TensorFlow's capabilities and applying these skills to enhance your projects, and remember that the journey of learning is ongoing. Thank you for joining us.